So hello, good evening and welcome to my first physics experiment. Today I'm going to be doing something that I think is one of my most exciting experiments because not only is it very dramatic, but you can do it with all the things that you have in home. So what you have is a normal drinks can. You have your hob with, I've got a metal thing here, but you can probably just as easily hold it there, although it's not quite as stable. It's just a metal gauze to go over the hob, and there's a bucket of cold water there. So what we're going to be doing is showing the power of atmospheric pressure and how it can, well, I won't say what's going to happen because I think it's so dramatic that I'll let you see what does happen. So what we do first is we put a small amount of water into the tin can just to cover the bottom, if the can will stay still. So I've already boiled some water, so we put a small amount in there. And then we put it over the hob, and then we turn the gas on and we wait for it to heat up. So what we're going to be doing is waiting for all the water. There's only a small amount, there's probably about less than half an inch of water in the bottom of the can. And we're going to wait for it to, all the water in there to boil, and so it's shooting up lots of steam through the tin can. So I'm just going to wait a bit longer. Until I can see lots of steam coming. I can see a bit of steam coming through at the moment. I want it to be really racing out, almost like as if it's a steam train coming out. So we're getting a bit more. Oh, the other thing is I've got some thick gloves on because obviously the tin can is going to be very hot when I do it. The other thing that I have got are these tongs, but not everybody has got these tongs. So I'm really showing you what you can have at home. So we're getting a lot more steam. You can actually, nearly there. So let's have a go now. We get hold of the tin can, we turn it upside down and put it in the water. Ow! And there you can see it almost instantly crushed into that shape. See how quickly and dramatically it did it. Right, now what was happening to that tin can? Why did it suddenly collapse when we put it into the cold water? Well, let's go through it stage by stage so I can show you how atmospheric pressure is working equally at one point, but then it's not working equally at another. So here we have a picture of the tin can. So we've got a little bit of water there and we've got heat being applied underneath. And initially what we've got is atmospheric pressure acting on the outside of the tin can, but it's also acting equally on the outside. So we've got balance at that point. And then when we heat up the water in the tin can, what we're doing is we're dispelling air by producing steam. So what we've got here is all the air inside the tin can being displaced by steam. So we've still got equal pressure. We've got the pressure outside acting there, and we've got the pressure inside still acting at atmospheric pressure. But what we do when we then take it into the cold water, what happens is that the cold water causes all the hot air inside here, let's do it in blue, to suddenly condense and come down as water, and there's no air in there. So we've effectively created a vacuum inside there. So we've got all the pressure on the outside here, but nothing on the inside to create balance. So what happens is that then the can just collapses in on itself. Right, so here we are back in the kitchen laboratory, and we're going to crush a tin can of cloudy apple cider that my son has just drunk. So you've seen the explanation of how atmospheric pressure from the outside is generally balanced from atmospheric pressure inside, but when we create the steam on the inside and then we condense that very quickly by putting it in the cold water, we are then creating a vacuum on the inside because all the air has been pushed out by the steam. Then we create that imbalance, so we've got all the atmospheric pressure pressing on the outside of the tin can but nothing on the inside. So so we've got the water boiling there quite nicely. The steam's came out at quite a rate, so we'll turn the gas off, get hold of it, turn it upside down quickly. And there you can see it collapsed quite dramatically in on itself. End of experiment.